This conference will now be recorded.
Okay, so today we will start, we'll teach you how to make an image and how to share an image, uh, Docker image, right? So this is a very important session because we are learning Docker. The main reason why we are learning Docker is to make an image. So that's the important one. So the first thing is, what is Docker image? So if you remember in the first session, what I said, Docker image have a collections of file system, right? File systems means the files, directories, combination of it. So Docker image contains the few file system, and primarily it is containing the boot file system. Boot file system, we call it a kernel, right? And no, sorry, any VM image. Sorry, my bad. I'm using wrong word. VM image contain the boot file system, and then root file system, and then we have a user file system, and on top of that we have a application file system. So this is the any VM image, OS image you can call it. You have it. So, but in Docker image, what you have, we discussed last day also. In a Docker image, we have no boot. That means in a Docker image, we don't have a kernel. So you will find a root file system, then user file system, and then application file system. And this all things coming together is being called as a image. Got it? All of you?
Yeah, yeah, yes, yeah.
So remember, it's not a image. The moment we call it image, our mind start thinking about one file or something like that. No, it is not a file. Okay. When you think about a Docker image, think about a kind of Git repository. Yeah. In a Git repository, what you have? In a Git repository, you have a files, directories, subdirectories inside that file. So it's like that. So this is the file system. Image is nothing but a file system. Don't start thinking about it just a one file which contain everything, one package. No. So let me show you some image. So I've installed the Docker right now. If you see, I have no image right now. So the question is where the image is being stored. So image is being stored in on the location which is called Docker root directory. So Docker root directory is a place where everything is being stored. Everything, meta, images, container metas, and many things actually. So inside that, if you go, then you have to check for the storage driver overlay to. So there are a couple of storage drivers are there. Overlay to, offsets, and few more actually there, depends on the operating system. So accordingly you will find it. So here you have, this is the directory. Inside this directory you will find plenty of directories again, but where do you find it? The image here. In important files you will find here. There's nothing. Do-sh, if you do, see, it's 8 KB data because there's no images actually. Now what I will do, I will download one image from the hub. So Docker HTTPD image, which I used last time as well for the session, though you can download any image. Now Look at this here. When downloading is saying pull and something like that, right? So pull means what? So this is the one file system, one like that. So 6 file system it got pulled. Uh, have you seen this pull message somewhere else as well? Any other tools? In a Git, you might have seen this Git pull,
Yeah,
Git
Git
push.
correct.
Yeah.
File.
And I said, right, Docker and Git have a lots of brother and sister relationship kind of it. Docker image is also kind of repo. Git repo, anyways, I think you have a little bit of ideas anyways. So it's also repo. The only difference is these files in Docker is being stored in the SHA-256 and Git is being stored in the SHA-1 algorithm. So that's a difference. Both are same actually. So now these are the how many file system you got it? 5, 6 I guess. But where are those? Look at this. These are the one. So each of these file system, if you see, is identified. I mean, contains the 40 character hash value. That is how the Docker maintain the integrity of it. Okay. So if you see that which is having the most size, I just want to check that. Okay. So let me check this max depth. So if you see that this one is containing higher one and remaining is containing this one is also 62. So I'll go for this one. I want to show you something inside that. Okay, so I am inside this directory, div directory, and I find it this one. What is this? Anyone? Have you come across anything as such? So guys, any Linux machines you logged in,
It
you
is
find
like
this one only in the root, right? ls root. See here, this is my VM, and inside the containers, inside the image also you had the same thing because I said just now, right?
yeah, root file
Image
system.
root file system. No? This is the root file system. Some of the user file system under the home directory here,
Hmm.
and then some applications will be there in a bin folder or something like that. Here it is, bin. Correct now.
Yeah,
So this is the one. So here we have a 6 layers. So we call it these file system 6. You have it right. We call it a layers. So what is this? Let's understand in some image way. I'm not using slides because this way I get little bit of flexibility to explain in my way. Slides become monotonous again. So there is a one file system. This is the file system, and there is another file system, and there is another file system. So basically, this is a layer 0. I'll put it here. This is a layer 1, and this is layer 2. Okay. So here you have a root file system. Here, let's say you install Java, and then here you install Tomcat, just for the explanation. So here only Java will be there in this. So here we had a 6 layer, right? Maybe this layer we have only Java files. This will have only Tomcat files, and this is having root file system. So this 3 layers is called one image. Actually, you know what? You can call this as a also image. Image can contain one layer also. Image can contain 2 layer also. Image can contain hundreds of layers also. Not a problem. So image is having multiple file system, and these are called layers. But layer 0 should be always root file system. Now this root file system, it can be Ubuntu, it can be CentOS, it can be Windows, it can be any other stuff also. Got it?
So
Any
Rajesh, how
other?
will distinguish the particular file system is a root file system? I mean, when you download it, pull the image, we have the 5 or 6 file systems, right?
Mhm.
And I mean, how will distinguish that a particular is a root file system?
So what happens when you look at the image, Docker image, inspect image, and the image was HTTPD. This will give you complete detail about what exactly all this thing. So here you see these are the layers, okay, and here some more informations, some more information, and here you have a data directory. So upper directory, work directory, merge directory, all this thing you have it here. Lower directory. So for time being, you don't need to go into that depth because you will get lost. But think about it. Always the bottom layer is has to be root file system. We call it a base image. Sorry. We call it a base image. Sorry. Got it? So now, so plenty of base image has been already released by community. So if you go to the Docker image or Docker hub, sorry, and here you see they have changed the website little bit. Yeah, so these are the base image. Say 6,000 images you have in base. So Ubuntu is here, Alpine is here, BGBox is here, Debian, whatever. A lot of it you have it. Depends on what you want. Got it?
Yeah,
Yeah. So these are the base image. So again, to reiterate, Docker image is nothing but a collections of file system. These file systems are root file system, user file system, application file system. These file systems is creating one image. These image are the file system, we call it a layer. Each file system we call it layer, and the the bottom layer, which is the first layer, you can say 0 layer, is a root file system. And on top of any layers you have, that is, it can be your application or anything, it can be one file also, okay, anything, all this thing coming together and creating one image. So here I was showing you some all base image, means only this one. But when you go for, let's say, some other image, let's say Java, so this image you see here, Java, this bitnami Java and Java. So this image you will have a this two component, some base image plus Java. Let's say if I go for Tomcat, so Tomcat. So this you will have all three. Why? So Tomcat required Java to run. Java need root file system to run, and root file system required the boot, which is a host machine. Okay. So this is the anatomy of image. Are you clear now?
yeah, now got it.
Now what happens when you yesterday, I mean last session, we created one container from images. So what happens? So when you create a container, all this layer get merged into one layer, new layer, okay? And this layer you have a root file system, let's say Ubuntu, Java also, or Tomcat also, okay? So all three content of it you will have in the one layer only, okay? And this is called merge layer. But interesting thing, you know what? This is mount to one user. Remember yesterday, I mean last session, I said what is the definition of
Yeah, container.
container? Yeah. So this is merge layer mounted to one user, and this whole thing is called container. One user, one network, one MNT, and all kind of things. So MNT is this one. I would like to tell you one more thing. This layer also get mounted. There is a little complications. I don't want you to confuse it. But you know what? This a one more layer get created, empty layer. Let me change the color. You will remember this. This is the one. Sorry. Uh, Let me create a new one. So here there's one more layer which get created here. You know what? Any, let's say you logged in or application is running in this container. So the files which you're modifying here, this is being written in this layer actually. Okay, understand this. This is being written in this layer. And this is also being merged here also. Okay, it's happening so fast you won't realize. Anything you write, it's written in this layer, this directory. You can say it's a two directory. Okay, that will be simple. That be two directory of one layer. Okay, work directory, diff directory. So this directory, the new files is being stored here, and from here is being merged here. So that means you have all these files which has come from the image, plus whatever the file you created, you can see in the container. Little confusion, but I'll show you, then you'll remember that. Okay. So here, let's understand this way. I'm in this folder. I have only one image, HTTPD, remember. Now what I will do, I will create one container. Okay. I will create a container. So Docker run -itd HTTPD. So run Docker run -itd HTTPD. One container I created. Docker ps. See, this container is running. Remember earlier I have a 6 layer, right? Now you see I got two extra layers. But actually I said one extra layers, right? So one is a link actually. Let me show you. Do-sh. Let this is the link. Okay. So let me show you first. So Docker ps. So there's one container. Do you want to see the mount? See, this is the, look at this very carefully. This layer got created. It's a new layer, which I said is merging all the HTTPD layer into one. Inside the directory which you see is mounted to the container. That means whatever you have here, you see inside a container. You want to see that? See that. This all comes from the all the images of the layers. Got it? So that means all the layers, when you create a container, all the layers get merged into one layer and that get mounted to the container. This is the one. Mount, you run the df command, you will see that. Let me create one more container just to visualize that. Docker run -itd. See here. df-kh. See 2. So always I used to tell you, when you create a container, one mount get attached to the user. This is the mount. When the mount is coming, from where this mount is coming? From the image. What image has? Layers. Layers means file system. What kind of file system? Root file system, user, application, whatever it is. Got it?
Yeah, that is clear. And what about the there is one more, right? Where we are writing the file getting updated.
This is the 8 KB. 8K is a link actually. You don't have to worry about it. Let me show you. So here you see 2init got created. So this is the
Mhm.
link. The moment you stop the container, it will get disappeared. See, this is a 40 KB, but this one is not the real. This is the real. Okay, merged one.
So what is the purpose of that init? I mean,
This is the moment you are running the container. Let me show you. So they maintain some runtime environment. Let me show you. I'm stopping this container. So meta information you can call it,
okay.
and then says gone. Oh, it's still there. Oh,
Yeah,
the
still there.
container will delete. I think when you delete the container, it will be gone. So this is just for meta information. This
Mhm.
contains no files for the things.
Okay, good.
Okay, now the question is, I said when you write means when container writes a file, it could be application or it could be you also log in into the container and write some files. So where it's been written. So inside the layer, let me go inside that. Right now you see diff merged work. So merge is a mounted directory, but whatever container is writing a data, it will be written in a diff, and while merging it will take consideration into that directory also. Diff right now diff has nothing. Okay, diff has, oh, it has a user. That means when you create a container, this user got created, because user dynamically get created of the containers, right? So like that. So this directory got created, one local user for running the container. So let me do one thing. Let me go inside a container. So there's one container which I'm running, docker exec hyphen itd it and bin bash. And you see right now I'm inside a container. Now inside a container, I'll go to the OPT location and just faking out one file, rajesh.txt. Remember, this file I created inside a container. So theoretically, I said this file will be two places. One is in the diff directory, one is a merge directory. Correct now? Here also. Correct? So now let me come out of the container, exit. Now I'm out of the container, and now I'm searching for that file. Find dot name rajesh dot txt. See here. So actually, whatever you did, is making in the diff directory. but because the container is running, it is going to write in this also. So when you stop the container, merge directory will get disappear. Merge folder will get disappear. Let me show you. So Docker stop folder, I said the directory will get disappear. See, I stopped it, and now if I find the Rajesh, only one place. So that layer is there of the container. It will be there till you delete the layer, a container. But whatever you written in a container, it will be there. And the moment you start the container, again the merge directory will come, including the diff and then remaining layers. See, understood now?
Yeah, so basically it's containing some temporary kind of data when
Yeah,
until this container is running.
right. Yes. So this is the something which we have. So this was just to understanding the how image is been designed actually. So let me show you something about how can you design. So let's say my manager has asked uh, to design one for image for let's say Moto X app. This is the app. So what I will understand first, I will design what are the dependency. So Moto X required what? So Moto X required let's say some um, some framework. So nowadays we have a Spring framework, right? Spring Boot if you're in Java. So Moto X is Java application, so required Spring Boot. Moto X is a Python application, so you need what? Any Python framework? Django.
Django, yeah.
Yeah. If Moto X is a PHP application, then framework will be what? Then the framework would be something like a XAMPP, correct? XAMPP, LAMP. So now you have to find out. Sorry, Django, Laravel. Sorry, Laravel. Correct. Laravel is a framework. Now Spring Boot required what to run? Java. Correct. JDK. Django required what to run? Python. Correct. Laravel required what to run? PHP. XAMPP. Correct. No?
Yes.
So JDK required what? This is where you require root file system. So let's say Ubuntu, this say CentOS, this say Alpine, and all this stuff. So this is the base image. So what you can do? What you can do? So basically, you design everything. You can design everything. You say I'll take a base image, then add this one. So this is layer 0, layer 1, then you add layer 2, and then layer add which is application. This is PHP application, Python, Java. So combining together, this is become your image. Correct now? So that way you are saying, okay, I will develop each and every layers my own. So that way you can control what PHP version or what Laravel version or something like that. Got it?
Yeah.
But you'll say, no, no, no. I know what I need. I have a Spring Boot image or Django image or Laravel image already developed by someone else. I'll use that and only put the my applications. So those also you can do that. So here if you see that last which I showed you, this is the one. So this is the base image: BGBox, Alpine, Ubuntu, Debian, Amazon Linux. But directly you can go for Spring Boot also. Spring Boot. That will have everything. See here, this guy has anyone can develop any image, by the way. So G Elastic has developed this image 9 days before it was updated. 5 million download is there. So this Spring Boot will have everything. Or let's say you go for Laravel. Okay. So Laravel, this is the Bitnami Laravel. So this Bitnami Laravel will have everything like a PHP, Apache, MySQL, everything will have. Are you understanding?
Yeah, basically these are the base images, right? Or whatever like you wanted to, pull.
No, Laravel is not a base image, no. It's application. Base image is only this one.
Yeah, only Ubuntu is correct, correct. Yeah, my bad.
Yeah. So many people have come up and said, okay, I'll create a Laravel. I'll create MySQL companies and all. For example, let's say you are from the Microsoft. So you have created your own base image, application image. So like that.
Mm.
Okay. So now did you understand that, all of you? How do we design an image?
Yeah, yeah, Rajesh.
Any question? Okay. So now the question is, how do we create an image? That is a question. Okay. How do we create an image? How to create an Docker image? So there is a two method to create image. One method step by step using container. Another one is automation. Automation, you can call it Dockerfile. You have to write Dockerfile. So both the steps I will show you. Again, you have to get mastery into it. So let's have one requirement. Okay. So my manager came to me this morning and said, Rajesh, I want you to create an image and give it to me in the next 10 minutes. So I said, yes, I can do that. So I asked, what is the requirement? So he said, do one thing, take base as a Ubuntu. On top of that, install Git and Java and Apache, and then plus one HTML file. Let's say this is your application. This can be large one actually. And then give it to me and call this as a MotoX. Simple. Got it? So now the question is, how can I create an image? So first, this image, I'm creating it right now using the step by step method. Okay. Step by step method using container. Now, you know what? You have to create a strategy. You want this as a layer, one layer, one layer, one layer, one layer, and then you want to create one image, or you want this all in one layer. It's up to you. Okay. This is the best strategy. Separate layer is best strategy. But right now, because I'll download the Ubuntu image and I will make all these changes in only one layer, means only one container. But if you want to keep it in a separate container, whatever the steps I'm showing you right now, you have to always repeat same thing. Okay. So now let me show you the image, creation. So first thing what I do, I will go and take a one base image. So I know that Ubuntu latest. You can take an older version of Ubuntu also, 20, 18, 19, all this thing. So this is the latest 24, I guess. So I got an image here, you see. Now I'll go and create one container from the image. So Docker run -itd Ubuntu. So you see here, I got container. You see, you got a container Ubuntu first one. So this is completed. This is done. Now I will go inside a container and install Java, Git, and blah blah blah. So Docker exec -it container id then bash. Where are you? I'm inside a container. Now Git is there. Say it's not there. Ubuntu Apache is there. It's not there. So I need to install it. So can we install it? So these are Linux command. Ubuntu commands will work. apt get install get hyphen y. It's complaining git package is not there. What we do? These all Linux skills you need it. I need to update the container. It's lightweight, so I have to update it. Done. Now I am going to install the git. Why I did it, so it will not prompt you hyphen y and all kind of things. Done. So git is there. See, container has a git now. Similarly, I will install whichever the tool I wanted. So apt get install Apache tool. What is this? Install spelling mistake actually. And yes, here I did not provide y. What happened? Y. So now git is also installed. So same way you want to install any other application, I don't think so I have to explain to you. Like Java you can install and everything. So which Apache you got it? You got it, right? Now Java I'm not installing it because it will take 3-4 minutes. So just to avoid it. You understood that, right? All of you?
Yeah, Rajesh.
Yeah. Now what I want, there is one package which I have it, which is index.html. So where it will go? So index.html will go to typically web directory. So see user local www http something like that. What is this? Share? No, I am forgetting that locations. It's etc. Is Apache installed individually. So etc http no Apache 2. I'm just checking the location because I forgot that. So there is httpd.conf, which is here. So this is a web locations it will come. So document directory, there's one location, right? Huh. So this location is var www html. So that's a location in if you install Apache. So var www html. So this is the locations. I need to have a file index.html or something like that. It's there already. You can replace also. You can come out of container and let's say touch index.html. I'm creating it, fake one. Okay, this is the package and docker cp index.html to container and then colon and then copy this file. Oops, wrong locations. Oh, it's got copied. Yeah, done. It's 2 times copied. So this way you can copy. Again, you have to go inside a container and done. So if you see that here, whatever I wanted, I got it done and come out of this container. This container, the container which you see, is having everything. whatever I wanted. You want to verify from the outside also, you say git is there. See, you're running inside a container, right? Which Apache to which Apache to see, and you want to see the file which is existing inside a container. ls var www. See, is there, right? HTML there. So everything is there. What I did everything in one layer. That means container layer. I'll changes all made it in one layer. And now I'll make it this container as a image. So what we do? Let me show you. So Docker ps docker commit -m. Why you are committing? What is the message? So it has Ubuntu get Apache index, just a name, and committing. Who are you? Author Rajesh. And which container you are committing? This container. And then image name MotoX. Done. So this command will commit the changes done in the Ubuntu container. See here. Done. And Docker images. See, remember my base image was Ubuntu 78 MB. Now this is 263 MB. Okay, so now this is the new image. So this image is not containing Git and Apache and index.html. This image is containing the everything. You want to test that? Docker run hyphen itd motox docker ps. This is the one. So docker exec container get, you see, is there. So motox image is ready. Now this will have definitely complexity when you do that from the applications. Everything you have to deep dive. But this is the way we can create an image. Understood now?
Yeah.
But now let's say you want to keep it separate. So keep doing whatever the commit you have to do after git. Take that as a git as a base image, then Java. You have to repeat the same thing if you want to keep it separate. I want to show you one thing. Docker.
Or if we take the Apache as a like application image directly and use it.
Directly people are using it directly.
Okay.
Apache. And I'm showing you how to create an image.
Correct, correct, yeah.
You people are that I told you now. You can
Mhm.
take directly somewhere I said it. You can take it directly this one and use it. No problem. Just install MotoX application.
Correct.
Okay, so I want to show you one thing. Ubuntu, look at this here. These are the layers. Look at the last layer which was created in Ubuntu A04. I want to show you the layers of commit basically of that MotoX. So Docker history. This one. Look at this little carefully. One layer got added. So if you see that here, this is a Ubuntu. Okay. Oh, sorry. First one. This is Ubuntu. And if you look at it little carefully, this is Ubuntu also. So your extra layer which you committed just now, this one. And this layer has all of your files, Git, Apache, index, and kind of thing. Got it? Just like I was explaining it to you, right? Multiple layers.
Mhm.
So you created these layers.
Yeah.
Okay, so this is the way manually, step by step, we create an image. But you know what? In real time, you will create an image using Dockerfile. So you need to write a Dockerfile. So Dockerfile learning is very simple. It's not very difficult. Very simple. Provided you understand that what exactly you are doing. Okay. What exactly you are doing manually. Why I showed you step by step first, so you can easily understand Dockerfile. Okay. So what I did, so I take a base image. How do I take a base image? From Ubuntu. So here this is the information to take, tell what you want and which image to take. Who are you? Maintainer. Maintainer means author. Okay. Maintainer. What is that name? Rajesh Kumar. Your email ID also you can put it up. Rajesh Kumar .xyz. What you did inside a container? Run. What you did? I had updated it. Say get update. Remember I did first time. What else you did? Run. apt get install get hyphen y. What else you did? I did Apache 2 hyphen y. What else you did? I copy a file from the current location to container www. No. What was that? I forgot that. Var. Uh, I forgot the
HTML.
var www html. These are the things you did. So you see what is, you know what? These all are your Docker file. And whatever you did manually, and that's the reason I showed you steps, you have converted into Dockerfile. Run means whatever you do inside a container. Copy means copying from outside, you copy that from the inside. Author information, base image. And few more instructions are there. I'm just showing you to make it comfortable with it. And but you know what? I'll tell you this one. Here, this if I create an image from this code, it will create a multiple layer. One layer, two layer, three layer, four layer, five layer. Last demo I created only one layer, everything I did. So what people typically do, they basically add like this to avoid the multiple layers. Then you will see this one a lot. This kind of code you will see a lot. Got it? To avoid the layers. Let me show you one real one so you will understand that. So Docker Hub, let's say Jenkins. Jenkins is a very popular DevOps application, right? So you should see that. Look at the Docker file link. This image has created a Docker file. This Docker file has created image. Sorry, opposite way. Okay, so I'll explain it to you this image, this file. But before that, let me create a image because you want to see that. So here, create a file, Docker file, named it. Copy this code, save it, and then build command will be there. So Docker build -t moto x1 and then dot means Docker file is there in the current location. T means image name. See, whatever we did manually, step by step, it will Docker is doing on behalf of you, and then it will create an image. Same image will be created because I did not change any instruction. So each lines it will run as a steps, add layers, and create an image. Done. And now you see that Docker image. See Moto X1. See the size is also same because the instructions were same much. Got it?
Hmm. Yeah. So
So
this is
this
this will
image,
be the sorry. So this will be the same template, right? If you're going to create a Docker file, so
right? Yeah. So most of the time, what people do, they write a Docker file. But how can you write a Docker file if you have not done the manually? Because you need
hmm,
to understand, right? You cannot simply jump and do that stuff. As a developer, you are going to do that. Each and every steps you only know that, right? How to run applications. So
okay.
this is the way to create an image. But this is the production ready image of Jenkins. I would like to talk about it this one. From means they are taking the base image of JDK. Why? So JDK required because Jenkins is a Java based application. So they required prerequisite JDK. They could have done it like take a base image, install JDK, and then install Jenkins. They could have done it. But they typically took the JDK image with the JDK already. So that means they are running Jenkins on JDK 8. After that, they are installing some applications which is maybe prerequisite. Okay. Now you see ARG. What is this? So this ARG you can consider as a variable in Dockerfile. Sometime what happens? Some value you want to use multiple times. Let's say user is equal to Jenkins. So you want to use user multiple times. So what typically practice is been done, you set as a ARG and then declare at the front and then use it this variable every time. For example, say here is one is being used, here is being used like this. So ARG is like a kind of simple way I would say argument variable. Okay. Now you want to set something, some environment variable inside a container. I repeat, inside a container. How do we do that? env. Okay, env. And here this variable will be set inside a container. Again run, again creating some users and some users and group to run the Jenkins application. Here mapping the volumes, you can ignore it a little bit right now. Again run, again environment, again run. Again this is copying the file from the current location. Init.groovy they are copying from the current location to this location. That means uh, here you will have that init.groovy. See somewhere. Here it is. Okay. So init.groovy. After that, what do we do? Again here arg env arg run run and all. Remember I told you Jenkins is running with 8080 port, so they are exposing this is the web port of Jenkins 8080 and this is the agent port. So this two port is required. So if you want to run some web based application, this you are exposing. Again env. Now this line what exactly is doing, see here, if you look at this, I'll show you something in this vi docker file. See, in this image, this container will run as a which image. So whatever the user you have, sorry, this container will run as a which user. So whatever the user has defined in the Ubuntu, it will run. And it was a root actually, if you remember, root. Let me show you if you forgot. Come out of it. Run. Sorry. How to list out the which command to list out the user? W, right? See. Uh, did you get that? Okay, let me go inside that. How to go? IT bin bash. See which user is running the container? Root. Why the root has come? Because you see that my Docker file, I have not override it. So whatever the user you have in Ubuntu, it will be taken care. So now you want to override it. How do we do that? So you can create that user. So how do we do that? So first you have to create a user, run user add Rajesh. So here I'm adding a user, okay? Creating a user inside a container. After that user, Rajesh. Got it? So if you see that here, this statement will run as a container as that user, but before that, that user is being created somewhere on top. See here. Got it?
Yes.
And if you want to create an environment variable, you can create like this. Done. Tiny da da da. Now let me run this code. I want to show you it. I'm replacing the last image. No problem. Okay. And done. Okay. There is a warning for environment variable legacy have used format because this is a legacy code now. So I can change it, but it's not required. See this image I created 9 seconds ago. Now I want to show you MotoX. Docker run -itd. One container got created. Now inside that I want to go Docker exec -it and then this one and bin bash, right? Bin bash. See which user you are running right now?
Rajesh.
Rajesh. And you want to see environment variable? Some tiny or something you see here? Tiny version. This I added. So this line will set an environment variable and this line will set your container user, but make sure that user is available. Okay. Again copying and all. Now this is important one. This is the most important one. And here people are making mistakes. Entry point versus CMD. Okay. And this is the important one. So what is this? So here you can have a two option, entry point and CMD. You can have a both in one Docker file, or you can have a one also. So what is this? So though I will explain it to you a little bit here, but this is the major question in your interviews as well. And this is the major challenges in your development also. What to keep it, what not to keep it, and kind of things. So let me show you something. So if you see that Docker PS, you see command, these containers are running Ubuntu containers with a bin bash. And you see HTTPD container is running with HTTP foreground. Why? Running, I said container should be running with something, right? It can run with a bin bash. It can run with Apache, Tomcat, XAMPP, Django, anything. Spring Boot. It can run with XYG executable. It can PHP. It can run Python. It can be run Java. It can run anything literally. How do you define? So this is defined by CMD or entry point. Okay. Let me show you this image, HTTPD image Dockerfile. Hopefully I'll get it quickly. So this is the official image and everything is in GitHub. Okay. So you will find no problem. Go for the latest one. Where is the latest one? Can you help me? I think this one. And go for CMD. Search for CMD. See? Got it?
So basically, what is the difference? I mean, CMD and the for entry
No,
point.
that is we'll come back. We'll come back. Okay.
Okay.
So the question is, how can you, what you want to run in the container So for that, you have to define entry point or CMD. Agree with me?
Hmm.
So Jenkins guys have run this shell script with using Bintini. Now, why the Bintini has used with this shell script, why this hyphen hyphen is there, this is, we need to spend some time to understand the program, I mean development activities. Because shell script you can run with the entry point, but it will run an exit. For that you need a Bintini, and Bintini required few parameters in this certain format. So many multiple utilities are there. So my say was, if you want to run any executables, and when I say any means any executable, Python, PHP, Java, shell script, any XYZ, LS, anything, what you need to use? You need to use entry point or CMD. Got it clear?
Yeah. So this is basically like when running, you want to run some application. So that details should be provided on entry point or whether on CMD, right?
Right.
Is it?
Yeah.
Hmm.
Yeah. Okay. Now the question is, what is the difference between entry point and CMD? So here, you know what? Entry point, set your PID1 of the container. CMD, also set your PID1. Now the question is, what is a PID1? So PID1 is the first process of container or system. See here, this is my system. Okay, this is the PID1, first process. This is your kernel. But in a container, you don't have a kernel, right? So what do? Let me go inside that container, docker exec hyphen it, enter, windash ps. See, your PID1 is bash. That's a, that because of the PID1 only, the container is running. Because of the PID1 only, your VM is running. Because of the PID1 only, your operating system laptop is running. So that runs your everything. But the only difference is, in the laptop you have operating system like a kernel, and VM you have a kernel, but container we do not have a kernel. Remember that. So entry point can be used for set your PID. CMD can be used for set your PID. But you know what? If you provide both, then entry point will run, and then CMD will become a parameter. Entry point will run, and CMD will become a parameter. Okay. Like example, for example, let's say you entry point you set something like bash, and CMD you set ls. So in container it will run bash ls. Okay. So it's a high level, it's a simple way to explain. This is the one, but again you have to again deep dive into that. This is the one of the topics which you should spend multiple hours for it. Got it?
Yeah. I think
Okay. Now best way, I will ask you to look at the example Docker file. For example, I was showing you this Apache. Last time I show you HTTPD. So look at your exam, some requirement, what kind of applications you are running, and based on that, you look at that what can be, how can we design it. So for example, let's say you are running some WordPress applications. WordPress is a PHP application, right? So Docker hub, and click on this, and here look at their um, Docker file, and this is a Docker file, and go to the CMD part and entry point part. Now they are using this one. There's a shell script with entry point, and they're using CMD also. That means what I said. When you run this container of WordPress, your PID one will become this one, space this one, right? Now the question is, what is this is in this script and what is this executable? This is your learning process for applications. So you will find here, this is the file, and this is executable. I guess is a part of Apache. Got it? Let's say some other application also. Look for the trends and you will slowly build that understanding. Okay, so now the question is, how can we share an image? I have built so many images, 2 images I built, but how do I share? Because my manager said you have to develop an image, that one, and give it to me in 10 minutes. But it's been more than 1 hour, I've not given. So I need to share, right? How do we share? So guys, there are many ways to share an image. One of the public ways is Hub, Docker Hub only. Docker Hub. Okay, this is the most popular way you can share an image. Now, most of the organization, they are using the private hub, actually private registry for storing an image, because they don't want that outside people to access it. But Docker Hub, you can buy that premium services and host your private repo also. But let's say if you're using free of cost, then it will be public except one. But there's one private, you can keep it. So my username is DevOps School. Anyone can create an account, and password is this one. Okay. So this is the repository which I have created a couple of years actually. It's bad, like there's no way to delete everything in one go, because I have created so many. It will take almost one day to delete, and this is so I'm thinking, should I delete the whole account itself, or so that to save the storage? Okay, so I will create a one repository at Hub, and this is a Moto X, and it can be public or private, but private only one is allowed for the free account, else you have to buy a premium services. So I'm creating public and done. Now you have to spend some time, don't rush. Your image name is this one at Hub. So whatever the name you have here at Hub, it should match it. So first of all, let me log in it. So Docker login, enter, and now my user ID is DevOps School. Okay, okay. So I think, you know what, password they have. If you want to log in as a password, you have to do this. Okay, so a little bit of change. So they have logged in, allowed through browser. So let me browse. Let me allow through browser actually. That way it'll be easy, because to be honest, I don't remember the password. I'm doing after so many days. So I just logged in through some web method, and in front of you, and here it is. But if you want to log in using the username and password, this is the way. Okay, so I logged in. Now what do we do? So I will go and check image name. So here, image. So Moto X, here you see Moto X, but the image name have at created this one. So this should match. What do we do in this case? Label it. So Docker tag, there's a command called tag Moto X1 to this one. So it's like a tag, it's not duplicate. It's a still, both tags are hitting to the same image ID, but tag is important, repository tag. Now what I'll do, Docker push, remember push pull, push after login, push this, enter, Done. So now what you did, I created an image, created repo at hub, matched the name of the repo, and pushed it. That's all after login. And now anyone in the whole anyone in the whole world, those who wants this image, is a private view, okay? Public view, you can get it, click here. Means anyone who wants my image, which is the Moto X, now come here, documentation I have not done, and you see they can download, copy this, see, pull and latest. So what he will get it? He will get it the Ubuntu base, Apache, Git, and index.html. I shared with it. So this URL I'll share with my team manager, and they will do the same thing which you have already seen multiple times: pulling, running, and testing. Understood now, all of you?
Yeah.
Okay. So now this is the way we create an image. I would like you to spend some time, all the reference tutorial and details, slides and all, I'll send it to you through WhatsApp. But spend some time and practice it and see how it is helpful. Okay, any questions now?
Yeah, I think I need to spend some time on like on doing some practice. Okay, so I just like means we creating the VM on WS, right? Sorry, AWS. So if we don't have account, like then where we can practice these things?
Yeah. So there is a two options. One option is like you can create an account and AWS. You will get a 1 year free services. So probably that will be better. But
Hmm.
for high-end machines, let's say 4 GB and all, it will be paid. So what you can do, uh, create an account, free account, create an instance, use it for 1 hour, 2 hours, and then destroy it. If you make a mistake, then again you have to set, it will charge you a credit card or whatever it is. But if you use for 1 or 2 hours, it will cost you 20 rupees or 30 rupees max. So that is a one easy way. A second way is like if you have a laptop, then you can create a VM, the VM which you can create on AWS. Remember, whatever the VM you have on AWS, you can create local laptop also. But for that, you would need to have some memories and CPUs and all kind of things. So if you have a 16 GB RAM, i5 and all, it usually you can create a 2 3 VMs in your laptop also. Now the question is, how do we create a VMs in laptop? For that, one video I'll share with you. For 10 15 minutes of video is there. Just you can follow and then create it. So both
Okay.
option I would suggest go for AWS, because
Yeah.
anyways that is something which you have to learn anyways. So if you have your own account, you get a freedom. Yeah, of course, little bit of money you have to shed, but it's a worth of until you will lose the money, not for the learning, but you lose the money for being lazy. Because let's say if you create an VM and then you keep running it for
Yeah.
multiple days without using it. So it's a mistake. For
Mm.
example, I created one VM and I will destroy just now after this training. So I have to pay only for that whatever the hours you have used it.
Got it.
What? Yeah. Okay, so tomorrow we will have a new session, new tools.